Hello, Shanmati. Hello.
Do you see me?
Yeah, no. Actually, I am able to hear you, but I can't see you. You can turn on video as well as yes. Now I'm able to see. Yeah.
So you can see me?
Yes, I can see you. Can you just cross check the screen? Uh, you can share the screen and see whether it is how it is coming. We'll cross check it.
I have to share my screen.
Yeah, I'll give you access. Right, just hold on. I'll just give you access. Then you can go to share the screen. Yeah, now you will get the access. You can just share the screen and see.
See how I have to share it.
Now there is at bottom you can see share screen option.
Okay, that one we have to share it. See, this they cannot download, no?
No. Nobody can download that.
Is it
Nobody
okay?
can download.
You can able to see?
No. Yeah, now it is okay. Yes. Done. You can just move the slides once, so that we'll just cross check. Okay. It is moving. It is moving.
Okay, no?
Yeah. Right. Good. Yeah. Now you can just off the screen. Then we will just pass a while. Then we will start at 4 o'clock. Okay.
Yeah, I don't know how to pause
Escape.
it.
You can keep escape. Give escape option.
Okay,
Then it will
then
go. Or stop share screening. On the top you will get that. Yeah. Done.
okay,
Now
no?
yeah. Now it's all perfectly all right. We'll just pass a while. Okay. You can unmute and you can off your video. We'll start at 4 o'clock. Okay. Thank you. Yeah, let us start the session. Shanmati, I'll just introduce Madam, then I'll hand over the session to you. Then you can start, okay? Slowly you can start so that meanwhile the participants can join, okay? Because since I have another meeting, so I have to do this. Thank you. Good evening, all the participants. I welcome you once again back to this AICTE sponsored online 1 week short-term training program on soft computing tech. Am I audible? Hello? Can someone confirm me in the chat box? Can someone confirm me in the chat box so that we can start the session? I think this is now. Oh, now is this all right? You are able to hear me properly? Hello? Hello? Thank you. Thank you. Yeah. Once again, I welcome you back to this AICTE short-term training program on soft computing techniques in civil engineering, the structural, water resources, geotechnical, remote sensing, and transportation applications. We have entered on day 3, session 2. And today, actually, our expert and speaker is Dr. Nisha Radhakrishnan. I would like to quickly introduce the professor, Dr. Nisha Radhakrishnan. Dr. Nisha Radhakrishnan is working as Associate Professor in the Department of Civil Engineering at National Institute of Technology, Trichyapalli. And she's having a unique academic background with PhD in Global Positioning System from Department of Civil Engineering, IIT Bombay, and has obtained a master degree in remote sensing. And her research interests includes application of geospatial technology and urban planning. Her research interest includes application of geospatial technology in urban planning with emphasis to land use, land cover assessment, quantifying the urban sprawl, analyzing the relation between land use and travel demand, site suitability analysis for urban residential development, land use transportation interaction, GIS-based management system, and so on, many more. So she's working with transportation division in the Department of Civil Engineering at NIT Trichy. She's carried out impactful project with 2.25 crores in the domain of land use, land cover assessment, urban planning, transport planning, and ITS. She has completed one DST sponsored project as principal investigator and one project sponsored by Center of Excellence in Urban Transport Department of Civil Engineering, IIT Madras, and Ministry of Urban Development as co-PA. Adding to that, she is also one among the core members of MHRD Government of India for the sponsored Center of Excellence in Transportation Engineering, CETRANS at NIT Trichy. She has completed 2 PhD scholars and currently guiding 3+ scholars in the areas of land use-based urban planning, land use-based transportation planning, and flood modeling. She has even guided 24+ PG dissertations in the same similar areas and over this 8 years, and is currently guiding 4 more PG students. Dr. Nisha Radhakrishnan has published her research outputs in leading journals, including Journal of Geological Society of India, Journal of Indian Society of Remote Sensing, Journal of Remote Sensing and GIS, Geomatics, Natural Hazards and Risks, the Arabian Journal for Science and Engineering, International Journal for Scientific Research and Development, the IUP Journal of Earth Sciences. Adding to that, she has in total 12+ international publications and 7+ national publications in the areas of GPS, remote sensing, and GIS in urban planning, land use assessment, and transportation engineering. She has over 40+ publication papers in international and national conferences on geospatial technology, transportation engineering. She has been serving as in different administration roles at NIT Trichy in the Department of Civil Engineering. Adding to this, she has also a member of professional societies like Institute of Engineers India, Indian Society of Remote Sensing, Indian Society of Geomatics, and Indian Geotechnical Society. With this introduction, I would like to thank Professor Nisha Radhakrishnan for accepting our invitation. Because of some personal reasons and commitments, she is unable to. She is unfortunate to present today. Instead of on behalf of her student, Miss Shanmati Rekha, she is currently pursuing her PhD and she has submitted her thesis. She will be handling our session today for this session 2 on day 3. Shanmati, thanks to you for your presence on behalf of our Nisha madam. I would like to hand over the session to you. Please go ahead.
Okay.
Yeah, I'm very sorry for the interruption because the other meeting actually started for me. So please continue. I'll rejoin in the middle. Thank you.
So, share the screen. Okay, good evening to everybody. And I'm Shanmati Rekha. I'm a research scholar in NIT Trichy. So I'm here to present the topic Geo-Information Techniques for Civil Engineering Applications. And the word Geo-Information Techniques, it is the combination of remote sensing and GIS. So the first technology, remote sensing. So remote sensing means in our body itself, we are having 5 sense organs. And in that 5 sense organs, 3 are remote sensing. So before seeing the remote sensing, we'll see like touching and tasting. We will be having a direct contact with the objects. When we are touching it, and we will feel very cold or very hot. So when you're tasting it, we will be finding it spicy or it's sweet. So it has the direct contact with the object and we can get the information. But the rest of the 3 organs, that is viewing, hearing, and smelling, we will be without having any contact. We could view the pictures and gather the information, and by hearing, you can able to gather that, and by smelling itself, you can tell it is a good smell or a bad smell. So this is the basic principle of remote sensing. So the basic definition given for remote sensing is the science and art of obtaining information about an object or area without having any physical contact with the object. So this is given by the Lillesand and Kiefer. So why not the conventional method, and why we are adapting the remote sensing techniques? Okay, the conventional method doesn't have the systematic data collection and process. So in remote sensing from the 1860s to till now, the systematic data collection process is there, and 3-dimensional of the area of interest. So if we want to study the 3-dimensional of the city, then we would be able to do it by using remote sensing. And repeatability, so time series. If we want to study the monsoon and the urban sprawl for between the time period, it is also possible. So global coverage means the area whichever in the earth can be studied using remote sensing, and those regions which we cannot go in person and we couldn't collect the data, that area is also can be studied by this remote sensing. So it takes the inaccessible region data also very easily. So it has multiple information for the analysis. So that's why we are adopting the remote sensing technology. So how it evolves, the history. So the very first remote sensing data is the photograph. So in the year of 1839, the first photograph has taken. Later it has been updated to the aerial photograph. And later on, this has been developed as the satellite photo images. So the first photograph, that the camera has been fixed in the air balloon, and this has been taken. So in the year of 1858, the rectangular picture and the oval picture was being taken in the year of 1860s. So how this process of remote sensing takes place? So the main source for the remote sensing is the sun. So the energy that is emitted from the sun, the radiation that passes through the atmosphere, and it interacts with the objects, earth objects. And then the energy radiation that hit from the earth feature, it again travels through the atmosphere. And then the sensor that is mounted in the satellite, that is placed in the space, will detect the radiation, and then it will stored in an analog form. Okay, then we will be given by reception, and the processing station will retrieve the information, and then through some processing, the data will be distributed to the users. So the radiations. So the radiation emitted from the sun will be the electromagnetic radiation, and this radiation which travels will follows the basic wave theory. So radiations, when it comes to radiation, we have different types of radiation, and this different types of radiation will vary based on its wavelength and frequency. So when it coming radio waves, X-rays, gamma rays, there are so many radiations. Like visible light also is one of the radiation. This is collectively known as electromagnetic spectrum. So this electromagnetic spectrum will follow these similar properties like a law of reflection, refractions, diffraction, and polarization, and the travel speed. So different types of radiations will have the same properties. So these are the radiations that radio waves have high frequency, and infrared, visible light, ultraviolet rays, X-ray, and gamma rays. These are the different types of radiations. So in this visible light, from 400 nanometer to 700 nanometer, the visible light is false. So the energy that hits the object, the incident energy that is from the earth, will distribute it into three forms of energy. That is, some of the energy will be reflected from the object, some will be absorbed by the object, and some will be transmitted between the medium to medium. So here the basic principle is law of conservation. So this reflected energy which is going into the space will be recorded by the sensor. So sensor will be mounted in one platform. So the sensor should be carried by any platform. So three types of platforms are there. So one is ground-based platform, another one is aerial-based platform, the third one is space-based platform. So ground-based platform, if we see handheld spectrometer, and then the vehicles. So the sensor will be mounted in the vehicle and it will be moving. So the data collection will be done. So the aerial based platform is the sensor will be mounted in the aircraft at the bottom of the aircraft, and this will the aerial photographs will be taken. The last SPACEBORNE is the satellite has been launched, and the sensor will be placed in the particular altitude. So SPACEBORNE platform. So in the SPACEBORNE platform also, we have two types of satellites, that is geostationary and sun synchronous. So this satellite is classified based on the altitude where they placed. So geostationary will be the satellite that will be placed above 36 kilometers, nearly and equal to above 36 kilometers, whereas sun synchronous will be placed within 1000 kilometers. So if we see geostationary satellite, it will be placed 36 kilometers. So in a shot, it can take half of the earth. It can cover half of the globe. Whereas sun synchronous, which is placed within 1000 kilometers, will cover less area. But the resolution, the picture quality will be very high. So again, based on the weight, the satellite is again classified into 5 types: small, micro, nano, pico, and femto. So this is the weight that is assigned to each category. So the emerging platform. Nowadays, the new emerging technology is the UAV, like drones. So the sensor will be mounted in the vehicle and it can be operated by the jockey from the ground surface. And so this, which will be flying and will be taking the data. So like before and all, it was used only for the military purposes or for the surveillance of the boundary. But now we are some organization also using today to do the survey analysis also. To use this, we have to get the aviation permission to use the drone. So advantages. So spaceborne remote sensing, what are the main advantage? So spaceborne, because it is put it in the high altitude, it covers large area in a single time. So repetitive coverage, even if you want to study 10 days interval, how the variations is there or decades, the repetitive temporal data sets will be available for the area of interest. So physically inaccessible, as I said, in the remote sensing itself, it can take the inaccessible regions. Then computerized and analyzing. So the image which we get, digital image will be easy for the analysis. So lower cost and per unit. So comparing to the conventional like total station and digital station survey, the images which we are buying it from the ISRO will be cheaper. So historical data, as I said, you can get the data from 1860s to till now you can get the remote sensing data. And the main advantage is you can have the three-dimensional view of your area of interest by using the photogrammetry principle. So if you want to do the three-dimensional urban analysis, yes, it is possible. And you know, for hydrological modeling, also this three-dimensional will be very useful. Okay, every technology has some disadvantages. So what is the main disadvantages here is the launching vehicle, satellite launching is very, very high cost. And as well as one in all, for to set up in the reception station, it is also very high cost. And if some failure takes place, the whole amount which we invested will be go in vain. So that is the main disadvantage of these things. And this remote sensing data is widely used in many of the field. So some of the field here I'm saying is like meteorological. So to study the temperature, pressure, wind velocity, you can get the information from the geostationary satellite and you can do the analysis. And for oceanography, how the wave is there and the mapping of ocean currents and the sea surface temperature can be done by remote sensing data. So likewise, the glaciology and geomorphology, geology, transportation, topography, agriculture, forestry, and then hydrology. So in many forms, and more importantly, in the disaster management. Why it is very important in the disaster management? Because we can able to assess how much the area will be affected. So before the flood, how is the region? So after the flood, how the region has been affected. So the next 2 days, how it is getting affected. These all can be done easily using the remote sensing. So in the sea, if you see oils and mineral exploration, and if the oil tank will be in the mid of the sea. So if there is oil spillage, the remote sensing image will automatically detect the oil spillage. So for so many things we are using. Again, for the military, to surveillance the border, we will be using the military, the remote sensing data. So sensor, okay, the energy that the sensor that is mounted in the satellite. So what it is doing? So it detects the light that is reflected back. So this detector will be, this photon energy will be stored in the analog form. So here you can see the image, the real object will be captured by optics and stored in the charged coupled device, that is the sensor, in the analog form. Then by using the converter, we will be converting analog to digital number. Then the data will be retrieved by the base station. So from the base station, the image will go some rectification process, that is pre-processing. So that like so many errors will be happening. So geometric correction, radiometric correction. So the image will be rectified with those corrections, and then the digital image is given to the end users. So sensor, there are two types of sensor. One is active sensor, the another one is passive sensor. By the name itself, you can have some idea. Active sensor. So active sensor has its own source of light energy, whereas the passive sensor does not have its own light energy. So it utilizes the energy of the sun. So here, this active sensor can be used both in the night as well as in the daytime, whereas the passive sensor only can be used in the daytime because it uses the sun energy. So scanning method. So the sensor will be taking the picture. So scanning method will also, based on the scanning method, again two types of scanning mirror is there. So line of light is nothing but the how the flight travels. So that is the line of light. If the scanning mirror is perpendicular to the line of light, then it is said to be whisk-broom scanning method. So if the line of light and the scanning is parallel, then this is said to be a push-broom scanning mirror. So in a click, you will be getting one picture. That is, you can see in the first one. So likewise, for each click, you will be getting one tiles. So that is said to be a sub-scene. So when the flight travels, it automatically click 1, 2, 3, 4, 5. It automatically clicks it. So there will be some overlap in the images. So when you are buying an image for your study, you have to see how many tiles and how many subscene is falling for you. So with that, you have to first collect and you have to make your data sit and you have to correct this overlap, side lap will be corrected before going for the analysis. So I'm saying like for all the study, you have to buy the image. So for buying the image characteristics should be known. So this image characteristics is based on this resolutions. So this resolution is of 4 types. So what are the 4 types of resolution is? Spatial, spectral, radiometric, and the temporal resolutions. So spatial resolution is nothing but like it is 1 meter iconos. You can see that red color image. So it is a 1 meter image, which is of very high resolution image. So in this, you can see each buildings very clearly. You can draw the boundary of each buildings, and even the road. You can also get the road alignment also. So the next study, if you see list 3, that is 23.5 meter resolution. It is not very clear when it compares to 1 meter because it is 23 meter resolution. So you will know that, okay, here there is some buildings and the vegetation. So next image, list 4, it is 5.8 meter resolution. So the spatial resolution where you should be concentrated means while you go for a very in-depth analysis, like for urban planning. So it is of 200 square kilometer you are going to take a study and you are going to do the analysis. So for 200 kilometers, 200 square kilometer, you need a very detailed image. So you cannot, that time you cannot go for the 23.5 meter resolution. So it should be 1 meter resolution. Likewise, when it compares to urban, you will be getting a detailed high resolution image. Whereas when it comes to study of for vegetation or the forest cover, the medium like 5.8 meter resolution data is more than enough. So based on your study, you have to decide what type of resolution you needed. So another examples, this 10 meter resolution, 30 meter resolution, 80 meter resolution. Yes, the study area is same. The same area has been taken in the different resolution. So you can able to clearly understand that the 10 meter resolution, we can able to see more clearly, and the edges of the building are very, very clean to extract the information. Next comes the coarse resolution, like scales, pixels. Okay, so pixel and scale, we'll see the difference. If the scale size is same, and if you see the first, the cell size will be different. So the first one is 15 meter resolution. The second one is 15 centimeter. So in this also, if the cell size is very less, then your image will be high resolution. So you will be clearly identify what are all the different features that is available in that particular. Whereas in the 15 meter resolution, you can't able to, it is like moreover, it is not so much clear. So you can understand that there is some green color, and there is some road structure is there, and there is some building, but not clear up to this centimeter pixel size. Okay, next come the down images. So here if you see large scale, so 1:2500 is said to be a large scale because in this large scale you will be having a very high resolution data, but the area covered will be very less. So that in data covered will be very less, but the information will be very high. Whereas when it comes to small scale, that is 1:50,000 scale, the data coverage is very high, but the information you can obtain from this image is very less. So first spatial resolution is finished, and next one is the spectral resolution. So spectral resolution, so okay, like said, if you take an image, there will be one band image also. There will be multi-band images also. So as of the band increases, then your image quality will also improve. So this resolution is like, if the resolution is high, then the image quality will be high and it will be easy for your interpretation. So the single band image is said to be a panchromatic, and more than one band is said to be a multispectral, and hyperspectral is having more number of bands. So here if you see, normally in an image, mostly blue, green, red and infrared will be available. So in addition, in some of the shortwave infrared, thermal band, microwave band is also available. So the first one is the pan image, which is a single band image. The next one is the Landsat image, which is of multispectral band. So we can see the difference that the color can differentiate the different features available in the Earth. So IRS list 2. So here we are having the 4 bands. So band 1 is blue, and band 2 is green, and band 3 is red, and band 4 is near infrared. So in this image we can able to see that band 2 blue color is there, but here we cannot identify or we cannot differentiate in the single band image, whereas in the last you can see 432 FCC, which is false color composite. I have layer stacked these 3 bands together and I have showed you the FCC image. So when you are seeing this FCC image, you can able to interpret that blue color is the water body. So this red color is the vegetation. The other white color may be the barren land. So you can able to interpret. Whereas in the single band image, you cannot able to interpret. So that's why this layer stacking of the more number of bands will give you the high resolution. So 321. The band 321 is the true color composition. This is the true image which has been taken. So now I am using the F32, that is near infrared, red, and then blue band, so that you can see the difference. It will be more clear. Water body will be blue color, vegetation. You can see the difference. You can identify the features very easily. So spectral bands, as I said, each application will uses different spectral bands. For example, to study the water body, the band 4 and band 5 will be very good. Whereas when we coming to urban and residential band, the band 1, 2, 3 is good. The 4 and 5 is very poor quality and we will not be using those bands. And when it comes to quarries, we will be choosing only the band 4 because band 4 will show the more in-depth of the quarries. So based on your application, you will be able to know which are the bands that is very suitable for the study. So based on the band, you have to choose the images. Next is radiometric resolution. So based on the band, the radiometric resolution is also based. So 2-bit means 2 to the power of 2, that is 4. 2 to the power of 4 means the whole image will be classified into 4 levels. Okay. The next is 4-bit data. So 4-bit data means 2 to the power of 4 is 16. So the whole image will be classified into 16 levels. And when it comes to 8-bit data, the 2 to the power of 8 is 256 levels. So the whole image will be classified into 256 levels. Okay, now this radiometric resolution is 4 levels and 256 levels, same image, so that you can easily interpret the different features in the picture. So high bit data means you can differentiate it. So for example, maybe you are going to study about the vegetation. If 4 level is there, it will classify water, land, vegetation, and then maybe barren land. So vegetation will come into one classes because it has 4 classes only. Whereas when it comes to 256 levels, this vegetation will be classified into at least by 56 classes. So different types of vegetation will come into 56 classes. So how about 1 classes and 56 classes? It automatically give you the different features. So high bit resolution data is good for your analysis. Temporal resolutions. Temporal resolution is like for the study, if you're going to do flood analysis, like before flood 1 hour, how it is the situation. After that, after the like 3 hours interval also the data is available. So month wise, you want to see the seasonal variations. You want each month one data, then that is also possible. So studying the pre-monsoon, post-monsoon, so that is the temporal data sets. Then annual data sets. Annual data sets means like how the urban sprawl is there. So in 1995, how the vegetation is there. And in 1999, how the vegetation has been reduced, how the built-up has been changed. So long term also for land use planning, at least a decade information is needed. So that long term analysis also possible, how the topography of the urban area has changed, the forest cover, everything has been done based on the temporal data set. So when you are choosing a temporal images, you should be able to know whether for that particular study area, what are the different types of temporal data sets available with our government, so that before itself you have to cross check what are the images available and from which year to which year it is available, and we have to select the data. So we have saw 4 types of resolutions. So these are the satellite images that is distributed by our NRSC. And so we can see the spatial, spectral, radiometric, and the revisit period, that is the temporal resolution. Based on this, you have to select your images for your analysis. Okay. So, okay, we got the images. So satellite image will be different from our photography. So one should know how to visually interpret the satellite images. To visually interpret the satellite images, we should at least know some process. So the key feature to know how to identify the features means from the satellite image, these are the keys that is being used to interpret the satellite image. That is tone, texture, size, shape, pattern, shadow, association, and location. So we'll see based on the tone, that is color, and the texture, whether it is a smooth surface or it is some rough surface. So based on that, we will able to know, we will differentiate the thing. So from these images, it is one volcano body. So that blue color will tell that it is a water bodies. So in the satellite image, the vegetation will be in red color. So those red color is a vegetation, and the volcano is shown in the light blue gray shade. So this is how you have to calculate. Okay, coming to the next picture. green band, red band, and near infrared band. So 3 bands are there. So the combined of 3 bands together is given in the last one, the colored image. So in this, you can able to identify that this is a Nile land. How we are interpreting it, because the blue color, it is fully surrounded by water and it has vegetation, as well as some lands are there which is in white color. So based on this, you can interpret and you can tell that this is some island in the water body. So this is how you have to interpret the satellite images. So texture, you can see the first image. The first image is very rough images, and the next is there is some river is flowing there and there is some vegetation is there. It may be the forest or the mangrove forest or something. And the next image in this side, you can able to understand that this is a paddy field, like cultivation land. So you can see the texture itself, it will show that difference. So based on the texture, we can differentiate that this vegetation is different from this vegetation. So next is size, shape, and shadow. So size, shape, and shadows, like we can able to identify the building. Okay, if it is very high size and the size is very big, then it is not a residential building. Some okay, industry building or administrative building. So based on the size, we can able to identify it. So here with the shape, we can say that this is a man-made structure because it has the outline in a defined way. So this can be some playground. So like this, you have to by using the shape and size, you can able to interpret that this might be the playground. So here, aircraft is standing. So this may be some airport terminals. The next is pentagon shape. So it is a pentagon building. So based on the shape, you can identify, okay, this is a pentagon building. And in the next is some roads. Some roads are connecting with each other. So it is some ring road. And you can also see that there is some small shadow is there in the middle of that road. So you can, from that, you can interpret that it might be a bridge. Okay. So likewise, we have to interpret the satellite image for our analysis. And in this image, if you see, there is a cloud, and because of the cloud, some of the region is having the shadow. So those region we should not take an analysis for the interpretation. So the unshadowed region has to be interpreted. As I told, if you see in the first picture, there are 2 roads crossing. Based on the shadow, we will able to understand that this is some bridge. So it is in the high profiling. And in the next thing, you can able to see this one tank type of structure. So with that shadow, we can able to see that it is having a very high profile. So the height of the building profile is shown by the shadows. So based on that, we can able to identify that might be some water tank. So likewise, each keys will be used for the interpretations. This is the aerial photograph, and based on the aerial photograph, the shadow is falling. The camel is standing and its shadow is falling in this. And based on the shadow, we can also able to tell at what time of the data has been captured and the angle which the photograph has been taken. So when the image is going for correction, this angle is also one important factor. So pattern. So in the first image, you can able to see the drainage pattern. So drainage pattern, if you see, irregular drainage pattern is there. So in the next thing, there is some regularly spaced roads, buildings, everything is there. So based on that, we can able to understand that this is some urban areas that is planned with some roads and buildings. So next comes the third image is some vegetation, like vegetation is there, but it is placed properly in a proper dimensions. So from this we can say that it is arcades. So residential buildings. So residential buildings is placed in the regularly spaced roads, and so vegetation, like based on that we can able to identify. So again aircraft, you can see the okay, then with the aircraft and the space how it is been allocated, we can able to tell that it is an airport terminal. Next comes the association. So some object will always have relationship to the other object. For example, from this image you can understand urban will always will be connected to major transportation network, particularly the cities. The cities will always be connected with major transportation network. So in this image we can able to see that there is a railway, as well as the road network is also there, and high-rise buildings. So based on that, we can able to understand that this is the urban area, that is some city. And the next image you can see there is some water body is there, and here you can see some tanks, everything is there, and some so based on that, you can say it may be some power plant or sewage tank. Some based on that, you can tell that it is a power plant. The next is you can see the very big chimney type of structure over here. So based on this, we can able to identify this might be some industries. Okay, here it is having a very high profile of a very high height, and the shadow is giving the height of the profile of the mountains, and based on the texture we can see that this is very rough and it is having some glacial. So it is the picture of the Everest. So till now we acquired the remote sensing. Through remote sensing we have acquired the remote sensing data, and we also studied how to interpret the satellite image. Now how GIS is going to play a role in this technology. So GIS, the main components of software, hardware, and the data and the methods and the experts. So location. Using GIS, we can able to study the location. So like we can able to locate the best site where the location for the new facilities can be done. So those type of analysis can done in the GIS. So condition. So based on the forest fire, so which is affected the most, the condition of the environment can be studied. So climate change condition. So these things can be studied by GIS. Trends, how the trends means like, okay, the vegetation, how the trend of vegetation has been come down, how the built-up has been raised. So these type of trend, and then pattern. So the pattern is like distribution of facilities in the urban area. Okay, the spatial, how it is clustered to the urban city center, or it is distributed spatially. So those type of things we can study. So modeling, not only the current scenario, the modeling like prediction of the future. This also can be done using GIS. How GIS works? GIS will be working like it integrates the spatial, non-spatial information and do the analysis, and it first create its own database for the study, and it has many tools. Using the tools, it will do the statistical as well as the spatial modeling task, and the final output image for the each application will be obtained. So two types of data models is in GIS used for the analysis. One is vector, the another one is raster. So vector is nothing but it is a point, line, and polygon. Whereas when it comes to raster, it is a pixel data. So while doing analysis, you can either choose vector or raster. So it is based on the application what you are using. So vector data, for example, that polygon is that boundary is the spatial data. So the attribute table will contain the non-spatial data, like the boundary name and the demographic profile of that boundary. That is how much population they are residing within the boundary, how many facilities within the boundary, and then what is the area, like how much area is forest, how much area is water bodies, everything. It will tell the characteristics of the spatial boundary, that boundary, and it tells the attribute information will tell the characteristics of the boundary. So raster data. Here raster data is just the gridded data. So gridded data will normally basically have the pixel value. So here there is no spatial, non-spatial. It's just the pixel value. So from low to high, it has the pixel value. So this pixel value tells about everything here. So source of raster data, the raw image that we are getting from the satellite is basically a raster data. So according to your comfortability and the application, you can choose whether it is vector or the raster analysis. If you are going to study for the whole India, then you can go for raster analysis, because creating vector data is somewhat complicated. Whereas if you are going for a micro analysis, then you can adopt the vector data, because in detail it will give the profile of the urban. So for example, for crime mapping, we are using the two methods, that is vector and raster. In the first, you can see the red colored dot points. So those points are the high intensity where the crime will be reported. So whereas the same thing, how it will be shown in raster is the red color data. You can see the red shaded, that is dark to lighter region. So the darker red region shows the high possibility of the crime report where it is reported, and lighter area shows less reported area. So this is how the vector and raster will be shown, the results will be shown. This is the raster image. So raster analysis, see, for raster analysis, everything the pixel value. So based on the pixel value, the classes will be defined. So every classes will have a different value. So you can tell one can be one classes, that 4 and all can be all together one classes. 5, the value 5 will be another classes. So based on this, the raster analysis will be taken place. So vector versus raster. So what is the pros and cons of using the raster and vector? Okay, the creation of vector database is a complicated one, but the storage phase and analysis process will be very easy by using the vector. Whereas when it comes to raster, the database creation, there is no such database creation. So the data can be readily used for the analysis, but the storage space and the analysis of processing time will be very high when it compares to vector. So these are the some pros and cons. Okay, so these are the queries, like doing the analysis, you can able to infer what are the different types of result you can infer from the analysis by using the GIS. So proximity analysis, if you see some urban habitat and if you can see the red color road network is there. So what is the proximity to the road network? Whether that is a shop is there or it is proximity to the residential. So the study of those type of proximity analysis also carried out, and overlay analysis to check the some maybe the real world can have a different thematic layers, that parcel, that it may be a private parcel or a public parcel, and the district boundary, street and land use. Based on that, you can also do so many analysis using overlay analysis. You can calculate the land value, or you can see the how the what to tell, how the forest and how the land cover has been distributed. In future, how the land use can change. So those type of analysis can be done. And so the output we are obtaining from the GIS will show you the visualization of your solution. So this GIS is used in various technology. Again, coming the same remote sensing application here also we are using it in different types of applications. So some of the case study I just go through. So hydrological parameters. So elevation, soil, land use, rainfall, temperature. So these are some of the different thematic layers. So by preparing this thematic layers, and you can do so many hydrological modeling like HMS cross method, and you can do these profiling, so many modeling you can use it. This is one of the hydrological modeling. And forest fire. So forest fire, what is the factors that affects the forest fire, you can study. And you can also tell that how much intensity the place of forest fire happens, and where the fire engine has to go to suppress the forest fire. And then after the forest fire has been come down, how much area of forest has been detroited. So these questions can be studied using for remote sensing and GIS. So land use and land cover change. So this is the Landsat data, and this has been obtained for 1997, 2007, and 2017. So this data, which is a satellite data, which is of raster data, that has been classified by unsupervised classification, and based on that, it has been classified into 6 classes. Again for the same 1997, 2007, and 2017. So if you see in depth, the built-up area in 1997 is very less, whereas in compared to 2007, there is a vast increase. And when it comes to 2017, the built-up is occurred more than 70% of the area. So when it comes to cropland, you can see how it has been changed. So in 1997, it is very high, but in 2017, it has come down. So by using so many analysis like MCDA analysis, you can see how much area of water body is converted to built up. So how much of forest land has been detroited and used, and how much fallow land has been converted to built up, how the changes of land use, how it has been converted and utilized now. So that those type of analysis can be done. Okay, and this is healthcare site suitability. So based on the existing facilities, that is primary healthcare, the spatial accessibility index will be identified. So the red color is the settlements. So each settlement has its population. So some 6 primary healthcare center is there. So based on the existing healthcare, how the supply and demand, based on that, this index has been obtained. So if the index is very high, then the access to healthcare is very high. When the index is low, then they have no access to healthcare. So based on that, the first criteria is accessibility index, second is road network, and the third one is land use cover. So based on that, overlay analysis has been done, and the weightage has been allotted, and then the site suitability map for establishing the new primary healthcare center is being given. So highly suitable is where the place you can locate your new primary healthcare centers. The green shows the already existing where they have high access. So likewise, before we saw education, healthcare, now it is education. So this is the 65 ward Trichy map, and the private schools that is having from class kindergarten to 12th class is taken for the analysis. So based on the road network, the network done, and from each centroid, we can able to identify how much access of education has been done, and based on that, accessibility map has been created. So you can see that in the orange color. So the dark orange color region shows the high access to education. So the lighter region shows the very low access to the education facilities. So this is how the urban facility management can also be done using the remote sensing and GIS. Future, the urban planner and the policymaker should adopt these type of technology for planning the and establishing the new facilities. So thank you. Thank you guys.
Well, thank you, Shanmati.
Yeah.
Yeah. Now the session is open to the discussion part. So I request the participants to post your questions, or you can unmute yourself and talk. We can address.
Girish, should I stop sharing or what?
Yeah, you can stop sharing. No issues. We can have a discussion for 10 minutes.
Nisha ma'am?
Yeah.
No, actually, that is Nisha, not Nisha ma'am. Nisha ma'am is unfortunately not presented. So she is a research scholar, and Nisha ma'am, she is about to get doctorate. She has submitted thesis, so you can talk to her, madam. Yeah, please go ahead.
Excuse me, madam.
Yes, ma'am.
Ma'am, you were showing some Landsat images, isn't it?
Yeah.
3 decade you have analyzed. So how you have analyzed the land use map? You have followed any?
How we are using it means land use image we will be obtaining from the website, and we will be downloading those things, and by using the software, like there are so many software like NV and AirTAS. So based on that software, we will be classifying the raw data into 6 classes. So we have spectral library. So using the spectral library, we will be able to know that water body will have this to this digital number, like 1 to 50, the digital number will be, DN values will be assigned to water. So likewise, we will be assigning values to 6 classes, and then we will be, the raw image will be classified into 6 classes. And again, we will be naming the classes, that is land use, the built up areas, vegetation, and then barren land. So likewise, we will be doing it for 3 decades, and then we will be obtaining the change cover analysis.
You do not use any automation algorithm. You did not use any automation classification. No? It's a manual calculation you have done in the land use.
No. It is not a manual calculation. So see, the supervised calculation and unsupervised thing is we will be giving the NV software will automatically classify the images into 6 if we unsupervised classification, and then we will be naming the classes alone, and then again by using the tool we will be able to get the change detection automatically.
So ma'am, how you are checking the accuracy of the data, ma'am?
Ma'am, what? I couldn't get it.
How you are checking the accuracy of land use classification?
Okay, land use classification, how much accuracy is? So the data obtained will automatically give the, by using Markov model or something, we will be able to see the accuracy of the classification results. And also by the field investigation, we will also go to the field investigation and also take some ground control points, and we will also check the accuracy.
Okay, thank you, ma'am. Thank you.
Hello, madam.
Yes, sir.
Geographically, generally we are working in water supply sector. We need the profile of the pipeline. That means a profile of the ground level.
Oh.
So we need the contours for development of reservoirs and as well as pipeline profile. Where is the elevation is high? Where is the elevation is low? And it's precisely required for us 0.5 meters to 1 meter interval of the elevation model. Is it possible to get a 0.5 meter elevation model?
Okay, this is like a ground profiling and the pipelines profiling. So for this, yeah, by using remote sensing, we are having one equipment called ground penetrating radiation, the GPR equipment. So it is available in our institute, NIT Trichy. So in our college also they have done the pipeline profiling using the GPR, and we are also doing it for sewerage, how the sewerage lines is running inside the NIT Trichy. We have done through those equipment. So it cost around 10 to 12 lakhs something, and the accuracy is also in centimeter accuracy.
Okay, thank you.
Any other questions from the participants?
Girish, someone is asking question because I couldn't hear.
No one is asking question.
We are winding up, or is there any queries?
Hello. Okay, let's end the session, Shanmati. Thank you very much for coming and delivering lecture on behalf of our mission. Are you able to see how to collect hyperspectral image?
How to collect?
One is asking about
hyperspectral image. See, hyperspectral image is like you can get it from NRSC. The image will be automatically, it is available. Like a spectroradiometer is the equipment that is used to collect the hyperspectral image. So you can collect using those hyperspectral, or else even with our government also it is available.
Not freely available. Not freely available. Sentinel.
Freely available, ma'am. If you are having the equipment, you can go and collect it. But as of from the NRSA government, some data are freely available, but not all the data. But it will be available in the nominal cost. You can approach the NRSA Borne website so that you can able to know the information, how much the tile cost. So based on the resolution, the cost will also increase. So for example, if it is a low resolution image, then it will come around like 5-meter resolution image, which I bought 1 year back. It is coming around 1400 something. But very high resolution, 0.61 meter resolution, it is a quick bird image that comes around more than 5 lakhs something, that we brought it from
What kind of analysis would be done using Sentinel data?
Sentinel data is like actually I'm not I'm at urban planning and transportation, but Sentinel data will be used in some other applications like
Evaporation calculation.
yeah, it may be like meteorological based, and those type of study they will be using it. So
Okay,
I am
your domain is urban planning.
Yeah, urban and transportation planning.
Okay. Ma'am, what do you mean by urban speed monitoring?
Urban speed monitoring. So you can for speed monitoring of vehicle.
Yes, ma'am. How through remote sensing? How you are relating?
So actually, there are so many transportation instrument, that is turtle. So using the turtle instrument, then we will be fixing the one point, and the initial point, and the next point. So when the vehicle crosses these 2 points, the distance traveled and the speed we will be calculating is. That is how we will be calculating the speed profile of a vehicle.
No, ma'am, transportation is useful in a remote sensing field sector.
Transportation, yes, transportation is used in remote sensing. Okay, like planning the how well it is connected with the city, the places in access that it doesn't have the proper bus stop. So where we have to how to direct the bus route. So for those type of analysis, we will be using the remote sensing. So speed calculating of the vehicle, we will be using the videographic survey, or else like using the total like radar which is fixed in the instrument, we will be using that to obtain the vehicle speed.
Okay, thank you, thank you.
Thank you very much, Shanmati, for useful presentation, an excellent session. Obviously, you reminded me that NIT Trichy days. I obviously missed the NIT Trichy. Okay, but yeah, now I would like to request my faculty coordinator, Dr. Sridhar, to have few words. Sir, yeah.
Yes. Good evening, madam.
Good evening, sir.
You have given a good lecture for our participants. Initially, you started with the remote sensing. What is the remote sensing and all these things, and remote sensing process, and what is the spectrum means, what characteristics of remote sensing and remote sensing process you have explained is very good, madam. It is understandable to anybody. So, energy action with the features and what are the various platforms which are available to your satellite image, and all this given a very good manner, and it is very understandable to everybody, madam. You have shown the pictorial base rather than the what you call text information. That is easy to understand anybody. You have shown the image characteristics and band combinations also. Different band combinations you have shown, and panchromatic to false color composite bands. And another one, what is the importance of to process the from the image? How to get the extract the features from image? What are the type of skills we require? First, how to examine the image, and what are the I mean to say the image interpretation skills. Image interpretation, these things you have well explained, madam, and later you have explained very good in spatial temporal changes, what are the applications we are going to use, and how you have shown in images and all these things. Is very good, madam. Very good presentation. Thank you very much for good presentation to our participants. I'm very thankful to you, madam.
Thank you, sir.
Myself, I'm a remote sensing specialist. I did an PhD and MTech in Spatial Information Technology, JNTU Hyderabad and JNTU Kakinada, madam. It's a very good, madam. I think you are working on transportation applications using remote sensing.
Yeah.
Very good topics, madam. In future, we will also share your ideas with us. Anyway, thank you very much.
Thank you, sir. And I also very thankful for giving me this opportunity. And I thankful Sridhar sir for giving me the session, and also Dr. Girish for giving me this opportunity.
Thank you. Nice to see you after a long time. Thank you. Good luck.
Thank you. Okay.
Yeah, soon you will get a PhD defense, and just invite me. Okay. All the best.
Thank you so much.
Wish you all the best, madam.
Thank you, sir.
Right. All right. Yeah, you can leave. Thank you, participants. Thank you, participants, for your participation. And,
sir, Girish Gar.
Hello, sir.
Sir,
Yes,
morning due to the network problem, I lost the connection, sir. Please, could you give me the morning link, sir?
Morning. Your email ID. So email ID you can provide. I'll send it to you.
I have sent to your email, sir.
Oh, I didn't check, sir. I'm very sorry.
Please,
In a couple of minutes, I will definitely send you. Okay, sure.
Oh,
Thank you,
please
sir.
please provide me that one, sir. Thanks for your concern, sir.
Sure, sir. Thank you. Yeah. Thank you, sir.
Nazir Ahmad, sir. Good evening, sir. Baunara.
Good evening, sir. Good evening.
Okay, sir.
బాగున్నాను సార్.
మనము పద్మకుమారి మేడం గారి దీంట్లో కలుసుకున్నాం సార్.
ఎస్ సార్.
లాస్ట్ ఇయర్. ఓకే
సార్. థ్యాంక్ యూ.
Thank you, participants, for your participation, and we will meet again tomorrow at sharp 10 a.m. Meanwhile, today evening, I'll send you mails regarding the Enlogit software link. So I request you to go through the link and make it ready for tomorrow hands-on experience. Whoever is having that infrastructure facility, desktop and laptop, you can just download it. It is very simple to install the Enlogit software for hands-on experience. The next 1.5 day will be on transportation hands-on experience on Enlogit and Vision software. Thank you very much. Definitely, I'll send to that mail. Definitely, the feedback link I will send. I request all the participants to come back tomorrow's morning at sharp 10 a.m. Hello, sir.
Sir. 3 days links not complete, sir. Sir.
So that's all for today's session, and I'm thanking you once again. We'll meet you tomorrow in morning session. Thank you. Sure, sir. We will provide the PPT. So far, I have received only 3 sessions PPTs. Once I receive the rest of the PPTs, I will definitely send you through mails.